July the 12th, 2021. Guys, you're looking at information coming to us pretty much live from the Discover satellite. It's between the Earth and the Sun, and it gives us an early warning system of increased solar wind or solar density, the effects of a CME, or the solar wind temperature. What you're looking at in the green is the temperature of the solar wind that's streaming from the Sun towards our planet. Again, the Discover satellite is much closer to Earth than it is to the Sun, but it can, depending on the speed of the solar wind, give us up to about a 45-minute heads up. In the purple, you've got the speed in kilometers per second, and it's around 3, kind of bumping up towards 350 right in here. And the top is the density in centimeters cubed. This is the proton density. How thick of a cloud of solar wind is this? Will it have more or less impact upon our atmosphere and the entire planet itself because of the effect on our magnetic field lines that we call the shield? Now, what's going to happen today, there's a coronal opening on the face of the Sun, and when that happens, we'll take a look at it. The magnetic canopy is missing in that area. It's kind of like a magnetic cloud covering over our planet. It doesn't let a lot of that solar wind energy escape. It's caught up in that magnetic fields that are above the Sun, transferred back to the surface. But when they have an opening in that magnetic field and the Sun is turning Earth facing, that solar wind is allowed to stream straight towards our planet. And what is expected to happen today is this wind speed suddenly double to about 600 kilometers per second. And guys, you're well over 1 million miles per hour at that point. And what it does, and we've looked at it for years on this channel, is affect the Earth's tectonic plates. Now, it can affect Earth's weather, different things like that. It's going to affect the auroras. It will affect radio ionization. It will affect, again, in the ham radio region and communication type interference like that. But my main concern, again, tectonic plates. We've seen the recent uptick in California quakes. So if there's pressure on the plates now, and it seems that there is around the world actually, then any kind of event like this could trigger that. I've seen it before. Saw an X3 solar flare, which is stronger than this. It's a more intense impact, and it threw a coronal mass ejection. I saw it as Japan turned Earth facing that day. That solar flare hit it. Worst disaster in the history of mankind happened when the Fukushima plants melted down. So we know the effect of, we've been through that for too many years now, but I just wanted to put this out. Again, this is supposed to just about double this solar wind speed. That's going to double the temperature. It may lower the density, but again, the wind speed is expected to go to about double this, from 321 or so to 600 kilometers per second. And the main thing about that would be to watch, is it a slow rise with a gradual increase, or will it be a sudden wall increase on this purple line? We've seen it before, though. The CMEs and the solar wind increases like this can do two things. Again, you'll see this graph just rise slowly. Then the effect of the impact on our shields is not as much. The pressure can sit there and build up, and you can see events happening. But when you see a sudden impact wall rise, it's just like any other impact, more direct, right into the wall type effect. So keep your eyes on the earthquakes from this evening through tonight, and just be aware where you're at. We don't know what, again, what type of impact this will be, but we do know it's going to double this solar wind speed. Now, there's another satellite up that we use quite a bit, and it's called the Solar Dynamics Observatory. That's how it's marked in the links on our website. I mean, you call it the SDO for short. Notice your timestamp. I backed it up till yesterday, going into the latest images coming in this afternoon. And you see this black area, guys, that goes up through the center. A couple of days ago, this was more Earth-facing, which would be centered right there, guys. So it takes it a couple of days to travel 93 million miles. Even at these near 1 million mile per hour wind speeds. Also, there's been more solar explosion and coronal mass ejections from the sunspots that have turned around the sun and they're on the back side. They're throwing out CMEs on that side now, and you can see some of the explosions. You saw one right there on the right. All of that will be returning. We have a sunspot now that's right there. You just saw it flash a smaller flare. We're going back into the peak of solar cycle 25. And everyone asks this question. Well, if we're peaking back into the solar cycle, why are we in grand solar minimum? And it's a fair question, because what it is, guys, is the peak of all the cycles. You're going back for several hundred years now, was higher than the one after it. In other words, solar cycle 24 that we just came out of had some strong solar events during its peak, which is the middle of 11.8 years. But the intensity of the entire cycle was less. If you put it on a bar graph, you can see that you go back to solar cycle 23, it had a greater peak, and 22 a greater peak. So the solar cycles still have that intensity in the peak of each one, but the overall graph is decreasing. That eventually will go back up. Sometimes, like we saw in some of the cold times of moderate minimum and all, these things can last for years. There's low cycle. But again, when this thing kicks back up, which is doing now, we're entering into solar cycle 25, solar events will increase. You'll see more and more attention paid to the sun because of the potential for, one of the things I watch for is the effects on our tectonic plates. But the CMEs and the solar flares, guys, can pull a Carrington event. If you're not familiar with that, it knocked out the telegraphs back in the early days of electronics and communications here in the U.S. and across the planet. I mean, people were electrocuted that were operating these telegraphs, basically a Morse code signal, and the lines were seen burning from a solar flare. So you think about that, the effect of that on the modern grid, because very few people at that time had a lot of electricity, but they did have the communication up for the telegraph. So that would be multiplied thousands of times the effect, because the grid has been built much larger since then, and more people are dependent on it, unlike it was in those days. But it was called a Carrington event. If you're not familiar with it, look it up. This is what we're dealing with, guys. We're going to watch as these solar sunspots that are coming around on the backside re-emerge, because they can be just as dangerous on the second or third revolution as they were on the first. But right now, pay attention to the solar wind that is coming from that hole. It's expected sometimes during today or this evening. It's a heads up, guys. Be safe.